So let's see what is the project that we are going to cover in this module. So as I told you at the start of this module, this project will be related to conversion of temperature between Celsius and Fahrenheit and vice versa. We are going to implement this with the help of a single neuron. It is a simple machine learning model to convert temperature from Celsius to Fahrenheit. So it will not be very difficult, and it is a beginner friendly project which can be taken up by anyone who even does not know anything about TensorFlow and even deep learning. So what is the formula for doing that? As we know, the formula for conversion of temperature from Celsius to Fahrenheit is T of F is equal to T of C multiplied by 9 divided by 5 plus 32. So we are going to see how we can implement this temperature. Now, there are some objectives that we need to discuss before going into the code. So first thing is we need to forecast the value of variable y, and to forecast that we are going to use the values of variable x. So we are going to define variable y and variable x with respect to our problem when we are talking about the code. And of course, x is the unbiased variable and y is the biased variable, which will be dependent upon x. Regression and other things will be discussed in depth later if we go on to that part in this course. So at the end, what I am going to show you in this module is a graph like this with points ranging here and ranging here as well. So let's start. With the workflow in Python. Now let's start with the implementation of the project in Python. So the first thing that you need to do is you need to open up your Google Colab. I have already explained how you can do that in the previous module as well. Now that you have opened your Google Colab, you need to install the libraries. The first library that we are going to use is of course TensorFlow, and to install TensorFlow you need to write pip install TensorFlow. So let's do that. Let's write pip install TensorFlow, and now it is allocating us a memory, and other than that we need to bring in the data that we are going to work with. If you see right here, there is no data that is available to us for now. Let's wait until it initializes. Now let's bring in the data that we are going to use. So the data that I am going to use is available right here in my directory, and I am going to bring it in like this. Okay, so after this, now we have completed the installation of TensorFlow as well as adding of the data that we are going to use. What is the next step? The next step is to import TensorFlow as TF. So because let's close this window first and let's zoom it up. Okay, so now we are going to import TensorFlow as TF. Other than that, we are going to import pandas as PD. So for that, let's write import pandas as PD. After that, we are going to import NumPy, Seaborn and Matplotlib as well. So for them, I am going to write import NumPy as NP import Seaborn for graphical interface as SNS, and if we are going to use Matplotlib, we should bring that in as well. So matplotlib.pyplot as plt. So let's run all of these commands and let's install all of these libraries that we are going to use in this specific code. So there we go. As you can see, all of them are installed. And what is the next step? The next step is actually to read this data. Where is it? Let me bring it in again. I think maybe I copied something else here. Okay, so now we have bring in the data Celsius to Fahrenheit.csv as well. So maybe previously I imported the module 3 project. Anyways, so now we have this data. Let's close it up again, and this is it. We have imported all of the libraries. Now we can bring in the data frame by writing df is equal to pd dot read underscore csv, and after that I'm going to write whatever is the name of this. So there are multiple ways to do that, and the way I am going to do is I am going to just click rename and then copy it, paste it and write .csv so that we do not make a issue, right? So let's do that, and after that let's bring in a few more cells. Now we have the data frame, and we can check out the data frame by writing df so this is the data frame. These are the Celsius values and these are the Fahrenheit values. So it's a very simple project, and of course if we want we can check out the head of the data frame by writing df.head, and let's write 5 values here, and we will get the first 5 values, and we can also check out the tail as well, and we can also check out the information as well. So df.info, it is telling us that it is a pandas data frame, and other than that we can also use the describe command to see more about the data frame. So here it is telling us the count, mean, standard deviation, minimum and maximum that is available in this data. So what is the next step? The next step is actually I would like to show you how we can plot this data, and for plotting I'm going to use Seaborn right here. So let's do that. For that we are going to use SNS, of course, because we imported Seaborn as SNS. So let's write SNS dot, and we can see some sort of a scatter plot. So let's write scatter plot, and in this I am going to write x is equal to Celsius and y is equal to Fahrenheit. And what is the data? Data is equal to data frame. So let's actually write the FAH. Let's actually copy it from here so that we do not make any mistake. Normally I follow this methodology because that way there are not many errors. Okay, so this is the graph that we get. This is the Fahrenheit and Celsius scale, and this is the data that we have. As you can see, this is a very lenient shape. Of course it should be a very lenient shape because the relationship between Celsius and Fahrenheit is pretty much constant. So after that, what is the next step? The next step is to start building up the deep learning model for evaluation of what we are doing here. Okay, so the first thing that we are going to need is we are going to need XTrain. So as I told you, there are two different variables. One is x and one is y. So I'll write Okay, so it is saying that it is not callable like this. Okay, so I was supposed to use these brackets. Okay, so in the same way I can also write y train, the thing that we need to be able to be predict later. I'm going to put that equal to y, and in this I am going to write Fahrenheit. So let's run this as well, and after that let's make a deep learning model with the help of TensorFlow and Keras. So the first thing that we need to do is we need to make sure that we have developed the model instance, and for that I'm going to use tf.keras.sequential. So after writing that, we will be confirmed that we are using the sequential model to do this. So after that we can start adding layers, and in our case we are only going to use one layer. As I told you in the start, this is a single layer model. In the next module we will increase the number of layers. So let's bring in the layer. So tf.keras.layers.dense, because there is going to be only one layer. Okay, and in this I am going to tell it two things. The first thing is there is only one unit, and the second thing is the input shape is equal to 1. Okay, so after that we can ask for model.summary. So this is the most simple model that we can make with the help of TensorFlow Keras. Okay, so after that we can also give it a compilation strategy. So for that we will write model.compile, and in this I am going to write optimizer is equal to tf.keras.optimizer.adam, and with 0.5 learning rate, and then for loss I am going to use mean squared error. So loss is equal to mean underscore squared underscore error. Okay, so it is saying that optimizer is not available. Let me check it. Okay, so now that we have done the compilation, the next step is to write the epoch history. So for that I am going to write epoch is equal to model dot fit, and in this let's say epochs. So model dot fit, and in this I am going to write x train and then y train, and after that I am going to give it epochs is equal to 100. So I am a little bit skeptical about this name, so let's write it epochs underscore eval for evaluation. Okay, so after it is done with that, it will be actually a pretty simple one, right? And after it is done with that, what is the next step? The next step is to see the plotting. So we are going to use the matplotlib part for that, which is being imported as plt. So I am going to write plt.plot, and in this I am going to write epochs underscore eval dot history, and let me know about the loss. After that I am going to write plt dot title, and in this I'm going to give it a title, and the title that I would like is model evaluation. After that I'm going to give it a X label. So the X label will be something like iterations or epochs, whatever you want to call it. And after that I'm going to give it a Y label, and in the Y label we could have something like training loss. So training loss, and at the end we would be having a legend as well. So in the legend we will also be giving it training loss. So training loss. Okay, so let's see what we get. So there we go. This is our evaluation, and these are the iterations. This is the training loss, and this is how well our model performed. Now to check out the weights, we can also write model dot get underscore weights. Okay, so after that, what is the next step? We can also evaluate this model at a certain temperature as well. So for example, the temperature at Celsius is 0, and we want to evaluate the temperature at Fahrenheit. So we can write model dot predict, and in this I am going to give it the value C or 0, it is the same thing. And after that I am going to ask it to print out the temperature in Fahrenheit. Okay, and temperature in Fahrenheit is equal to, then after that I am going to write F. So there we go, it is giving us that the temperature in Fahrenheit is almost 31. So I think it is right, or we can say that it is almost right, because for example if we put it in the equation, it's a little bit different, it's 32, right? So of course if you want to evaluate that, we can do that as well. So F is equal to 9 divided by 5 and then multiplied by C plus 32, and if we write F, then it will tell us that the value of F is 32. So our model predicted very well. It said that the temperature is 31, it was 32 actually. So as you can see, this is the most simplest and easiest explanation of any neural network with the help of TensorFlow, and I hope that you have really understood how we can perform this evaluation with using a single neuron. So after this we are going to discuss about the quiz.